My presentation was on green infrastructure design training. This training is offered by the bank, and we have started this training, I think, since February this year. We've trained almost 125 engineers, architects, quantity surveyors, and urban planners. Next, please. Yeah, this is all about urbanization in Tanzania. As you know, Tanzania is one of the rapidly urbanizing countries in sub-Saharan Africa. Na mpaka sasa hivi population yetu ya watu wanaokaa mjini imeongezeka from 5.7% mwaka 67 to 34.9% in 2022 and is expected to reach 50% in 2050. Na hizi takwimu zimetokana na sensa ambayo imefanyika karibu. Next please. Na kwamba miji yetu sasa hivi ina jukumu kubwa sana katika uchumi wa nchi na vile vile katika kupunguza umaskini, na imeonekana kwamba miji ina shughuli nyingi za kiuchumi na contribute zaidi ya nusu ya GDP ya nchi, na kwamba maeneo mengi ya nchi yana shughuli hizo za elimu, na yameonekana kama ndio sehemu ambazo zinaongoza kwa teknoloji na hata kwa ujenzi. Next please. Hii ni namna ambavyo miji yetu imekuwa inabadilika katika takriban miaka 14 katika miaka 10 iliyopita. Ukitazama hii ni Dar es Salaam, na hizi zinaonyesha formal settlement na informal settlement, namna ambavyo zinakuwa, na kwamba miji yetu inaongezeka ukubwa wa watu mara mbili. The cities are doubling after every 14 years. Next please. Next please. So the World Bank has been doing some projects in Tanzania, and if you look at different since 2010 we had many projects in different cities in Tanzania and Zanzibar, mainly in Tanzania and Zanzibar, with the Zanzibar Urban Service Project, ZUSPU, and also we had the Dar es Salaam Metropolitan Development Project, DMDP1. We did also Tanzania Strategic Cities Project in about some of the secondary cities, and Urban Local Government Strengthening Program in other cities. So these projects have already been done, they are done, and we are also doing now some other projects, boosting inclusive growth in Zanzibar, land tenure improvement project. We have Msimbazi Basin Development Project, which has been approved, and we have Tanzania Cities Transforming Infrastructure and Competitiveness Project, which will be done in 45 cities. And we have Dar es Salaam Metropolitan Development Project Phase 2, which is now will be, I think, will be apprised today and go to the board end of this year. So if you look at those projects that have already started, zinazotengenezwa, the pipeline project ambazo zimekuwa approved, this is about $1 billion that will go to the cities for infrastructure development. Can you next please? And these are the cities where the urban and land portfolio from the bank is working. So as I've said, it's over $1 billion in urban development project and program throughout Tanzania. Next please. Some of the results that we have constructed 432 kilometers of roads kwenye miradi ya TSP na ULGSP ilifanywa katika miji ya Mtwara, Mwanza, Arusha, Iringa, Sumbawanga, Mpanda, Dodoma, Tabora. Whenever you go, you could see some of the projects that we did. So we constructed some waste collection points. No. Usiende bado, rudi hiyo slide ya nyuma please. Yeah, we also had some general planning schemes, 26 of them, transit facility, bus terminals, etc. We had even built some parks If you go to Chinangali in Dodoma or Mashujaa in Mtwara, you could see some parks that were constructed. And also, we could see even the local government on-source revenue has increased for about 457%. Next, please. This is for key result from DMDP1 in Dar es Salaam. We have constructed 207.8 kilometers of roads, 75 kilometers of trunk drains. We have we have improved the community upgrading in about 14 wards. And also we did institutional strengthening activities along the BRT corridor. We have a development strategy and also LGRCIS upgrade. Next, please. But we have learned many lessons out of this. But one of the key lessons that we've learned through implementation of this program ni namna gani urbanization inaendelea katika miji yetu, na kwamba tunaendelea kutengeneza iko trend yake inaonyesha kuna informal development, yani kuna maendelezo ambayo sio rasmi, na kwamba maeneo mengi ya watu wanaishi katika sehemu ambazo hazijapangwa, ambazo hazina huduma za kutosha, miundombinu na huduma za kutosha. Next please. Na kwamba maeneo mengi ambayo yanajengwa yanahitaji miundombinu ambayo yatasaidia yameendelea, yani baada ya kuwa kumejengwa, hayo maeneo yamesababisha kuongezeka kwa maji kutembea, na kwa maana hiyo yamesababisha mmomonyoko wa ardhi ambao umesababisha udongo kutembea na mafuriko, na kwamba kuendelea kujengwa kwa maeneo hayo wamesababisha hali ya miji iendelee kuwa na hali ya hewa ambayo ni ya joto zaidi, na kupunguza uwezo wa maji kwenda chini kwa ajili ya kurecharge groundwater tunayotumia kwa kunywa na kwa watu wengi ambao wanatumia visima. Next please. Kwa hiyo kuna effects ya urbanization ambayo imetokea. Yaani baada ya kuwa tunafanya maendelezo ya miji, tumeweza kupata mafuriko, tumepata mmomonyoko wa udongo, kumekuwa na ongezeko la joto, na kwamba tumeshindwa kurecharge groundwater, maji ya chini ambayo tunayatumia. Next please. Kwa hiyo kulikuwa na mtazamo kwamba tunaweza kuwa na green infrastructure. Yaani green infrastructure ni jambo ambalo hatujalitazama kwa upeo wake, lakini hii green infrastructure kwa Dar es Salaam manake itatusaidia kupunguza flow ya maji ambayo yanatembea. Kwa hiyo itapunguza the volume of peaks, na vile vile itapunguza mmomonyoko wa udongo, itasaidia maji kwenda chini, na hivyo itatuwezesha kupata maji ya kutumia katika groundwater, na vile vile greening inaweza ikatupa shade na evaporation, kwa hiyo kupunguza joto katika miji yetu. Next please. Kwa hiyo World Bank contracted ARUP. This ARUP is a consultant to undertake a study that is looking at the opportunities for urban greening and sustainable urban drainage and erosion control infrastructure katika Dar es Salaam. Now objective was to identify and map opportunities and quantify the benefits for the citywide urban greening, open space development, erosion control and sustainable urban drainage system. Collectively refers to a nature-based solution. Next please. Kwa hiyo unaona kwamba the opportunity assessment for green for urban greening, sustainable urban drainage and erosion control infrastructure in Dar es Salaam, this study was done, and we have just received the final report of that. And what is shown, the assessment was looking and comparing through the quantitative scenario and modeling of realistic, the 2022 and future 2030 and 2040 city baseline scenarios to develop as part of this study with and without the identified opportunities for NBS. So we were comparing what will happen if we can use this opportunity with and without if we do nothing or if we act accordingly to do the greening through this opportunity, what will happen in 2040 without or with the opportunity. So the modeling scenario also consider the impact of climate change in terms of temperature and precipitation. Next, please. So this is the result that was obtained. Nenda nyingine, slide nyingine. Next, please. So there are several maps that were obtained in the report, and this report can be shared. That we have some map, potential urbanization 2040. This map shows the potential pattern of to the extent of urbanization. We have the map of opportunity for urban storm infiltration shallow. We have the map for urban storm storage. We have the map for opportunities for urban storm infiltration. We have the map for opportunities for green, and also map for town road and network search. I mean, if all the town road roads are greened, we have that map. Next, please. We have the map for BRT route and deposits and urban greening 2030. We have opportunity for urban soil loss reduction 2030. We have the map for opportunity for riparian and soil loss reduction 2030. We have the map for opportunity to protect river and riparian areas. We have the map for opportunity for additional trees 2030, and a map for opportunity for additional trees 2040. Next, please. So in these maps, you can see the opportunity impacts of reduced flood hazard. If greening interventions are done, this will help to reduce the risk from frequent flooding. They also help to reduce flood risk during rarer extreme events. Next, please. So if the benefits include protecting 17,000 buildings could be less susceptible to flooding by 2030, 0.9 square kilometer of road and area will no longer flood, 12 square kilometer of urban area no longer flooded, and also reduce the impact on urban agriculture, building infrastructure, and disruption to livelihood. These were the benefits that were seen during this study. Next, please. So there's also a 4% reduction in soil loss by 2030, which is equivalent to 840,000 tons per year by implementing greening interventions as the city develops. It was also observed that there is a reduction. The reduction is broken down into the following interventions. That's 4% of road rated, 12% citywide, and also 80% riparian zones. Next, please. So greening interventions also helps to maintain the volume of stormwater, and it was also observed that approximately 730,000 cubic meter, roughly 300 Olympic swimming pools, more rainfall can be stored in the soil by incorporating green interventions into the city by 2030. Next, please. On the heat island, the slum has a maximum of urban heat island of 4.85% degrees Celsius compared to air temperature. With the projected climate change of the future urban scenario, the urban heat is projected to increase by 2% by 2040. But future greening interventions could reduce air temperature significantly between 1% and potentially up to 5%. Next, please. So the benefits of reduced urban heat island was also observed, and this is to reduce air pollution, heat-related deaths, and heat-related illness. So the reduction of urban heat island effect will also greatly benefit the low-income unplanned settlement. Next, please. So a simple shift from gray, this we are very much on gray buildings, a simple shift from gray building to green will really change, and this can be achieved, can achieve transformational change through practical measures. Like we have the traditional roof. If we go to green living roofs, if you look at road bollards, and then we go to street trees or street pits, which can infiltrate, allow water to infiltrate, and then allow the water to go slowly to the drainage systems. If we have, we are currently have engineering flood solution. If we go to SADS, which is Sustainable Urban Drainage System, soils and natural flood management, the standard road and sewers, we go to permeable paving, incorporating water storage in sub-base of the street. We move from single function, example, supersized water pipes, we move to multifunctional. These are the issues that we can do to reduce the effect that we have now. Next, please. So the quality of life really from green infrastructure, which can help the city change the life of the city. You could see the green infrastructure normally is welcoming, distinctive, safe and pleasant, easy to move around, resource efficient and adaptable. Next, please. So to cover the knowledge gap that exists, this is what we found, that there is a gap in knowledge in implementing green infrastructure in the country. So what we did was the World Bank, through a trust fund, has developed a training which was reviewed by ERB, Engineer Registration Board, and Architecture and Quantity Surveyors Registration Board, for exploring through green infrastructure design how infrastructure how infrastructure and development can be adapted to help mitigate impact of urbanization through incorporation of green infrastructure. So jamani, tulipata trust fund. Trust fund ni hela kidogo ilipatikana, tukatengeneza training baada ya kuyaona yale matatizo, na kwamba tusipofanya kitu kutoka kwenye utendaji wa sasa hivi wa kujenga bila kuingiza hii miundombinu ya kijani, tutapata matatizo mbele. Nadhani mmeyaona, if we don't incorporate green, miji yetu itakuwa haikaliki. Kwa hiyo ni wakati wa kufikiria upya na kurudi kwenye nature sasa. Now we need to use the nature, to mimic nature in our development, in our construction, so that at least we mitigate the impact of climate change. Twende mbele. Next. So the training objective was to understand how infrastructure can be designed or complemented to reduce soil erosion, flood impact, and increase groundwater recharge, and also reduce urban heat. So to understand how to plan, design, construct, and implement flood-resilient infrastructure, this was one of the objectives. And the last was to understand using results of hydraulic flood modeling in infrastructure design. This is now not much done. We are not using the modeling, the flood modeling, in our infrastructure development design. Next, please. So the training course, these are the training courses that have been developed. We have the green roof design. This is one of the courses that is being disseminated. We have sustainable drainage system. This is SADS. We have erosion control and infrastructure design using flood modeling. Of course, we'll also develop another course on urban cooling. This is also another course that we will develop under this training. Next, please. So if you look at the urban roof system, these are some of the, next, please. Can you move faster a bit? Next. This is just the definition. If you attend this course, you'll find all this in the course that is being offered. I'm just giving you the introduction of what is in the course. The green roof is a piece of nature on the roof. You could see this is chaff roof in Scandinavia, a pitch roof 10 to 45 degrees, and that's hanging gardens of Semiramis in Babylon. This is a very famous green roofs. Next, please. Next. These are the advantage of having a green roof. They start from improvement of microclimate, air improvement, water retention, increased noise protection, saving of energy cost, extending to of the roof life, increased biodiversity, and extended living space. Please, next, please. On the improvement of microclimate, you could see green roof improve the microclimate through evaporation and transpiration. So the result is a cooling effect. And for most of the builders, I mean, we are building buildings, but we forget this. Next, please. And also on the air quality improvement. You know, when you have a green roof, you can have plants binding and filtering dust. You can plants absorb pollutant, reduction of heat island effect through cooling effect, and also reduction of carbon dioxide. Next, please. On water retention, this is, of course, a challenge to big cities that so the solution is to have this that will allow for sponge effect and cooling and unsealing of surface and the relieving of sewage system. Next, please. This is, of course, increasing of noise pollution. Also, this is another advantage of green roof. Next, please. The saving of energy cost. This is known to all engineers that if you have a green roof, you can reduce the need for energy. Even the energy for cooling your houses, the air conditioning energy, will not be used as if you don't have the green roof. Next, please. The lifespan of the roof. This is over 100 years old. So you can even increase the lifespan of your roof. And this is over 30 years at the roof. How many minutes do I have? 2 minutes. Oh. Can you move faster, please? It also improved biodiversity. This is next. This is next. These are some of the examples that exist in Dar es Salaam. When you go to Hayat, we have the green roof. Next, please. This is Zanzibar, when they have Park Hayat Hotel in Stone Town. There is also a green roof. Next, please. We have, this is in Arusha, Grand Melia Hotel in Arusha. They have this green roof. Next, please. And then we, for engineer, the sustainable drainage system, SADS, these are also very, very important. And this is a range of solutions designed to manage stormwater locally and to mimic natural drainage and encourage its infiltration, attenuation, and passive treatment. Benefits include quality management. Next, please. Next. This is the old way, that we allow all the water to go through the drainage. We just have a big pipe, we allow all the water to go through the natural the drainage that exists, or the trunk drainage that we have, and all water goes. Next, please. Next, please. This is the SADS way. When you retain some of the water, you recharge the groundwater, and this improves the quality of the area. Next, please. So some components, in SADS, you need also to have source control, site and conveyance, and regional control. Next, please. This is one of the site control. We need to harvest water. Rainwater harvesting is one of the source control. Next, please. The swales. This is a part also used to reduce the velocity of the water. Sometimes we have these concrete pipes. We don't need concrete pipes to take water. You can use the swales on the roads or the pavement. They give you the greenery and reduce the flow of the water, so that at least you have the water that percolates down to recharge the water and also reduce the velocity of the water. Next, please. This is regional control. Next, please. This is an example of integrating SADS into development. You could see the permeable paving, green roofs, swales, soakways, rainwater harvesting, rain gardens, soakways. It's very important to integrate SADS in our development. Next, please. This is some of the example of the SADS, infiltration-based swales, bioretention areas, wetland, pervious pavement. Most of the people that we pave the areas, and then they do not allow water to go down. So we create a road or runoff which causes floods. Next, please. This is a more example of SADS, swales, pond, wetland, green roof. Next, please. This is an example of permeable pavement, which is very important for you builders. Okay, next, please. Next, please. This is normally SADS approach rain as an opportunity and not a threat. We are talking that we'll have El Nino, but treat it as an opportunity. Collect more water. Next, please. It's important to understand the hierarchy of rainfall day to day, and that the first flash, 10 to 15, normally are polluted. Next, please. Next, please. The cause in detailing sloping sites, service corridor construction phase, landscaping, and additional loading forces. If you attend this course that are being offered, this is how you will get the knowledge on all of this, the course is so detailed. Please, next, please. We also give another course. This is course number 3 on the design of erosion control for infrastructure. Next, please. Next. 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 Next, 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 next. This is for engineer. You know, you have to have your area. You have to model the area, topographical, soil, vegetation, land use, the rain, and then you get your cue. All these are obtained during the training. I know most of you understand, but you can get another chance for you to refresh on this knowledge. Next, please. Next, 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 next. No, you go back one slide before So the training targets practicing engineer, quantity surveyor, architects, urban planners, and managers. ERB and the associate institution will be responsible for the course dissemination in the longer term. A green infrastructure design training is being developed and to be incorporated in the university curriculums to prepare the future practitioners. Since its commencement this February, the course has already been delivered to 125 engineers, architects, quantity surveyors, and urban planners. Thank you very much. Asante sana.